In today's daily challenge, we have to accept an integer n as the input, and then we must print the count of integers from 1 to n which are having 1 as their first bit in the binary representation. And here we are also given that we must pad the leading zeros depending on the number of bits in the binary representation of n. So let us understand the question with a sample input-output. So for the input 10, our expected output is 3. Let us see how we are getting the value 3. So the number of bits in the binary representation of 10 is 4. So 1, 0, 1 and 0. So there are 4 bits in the binary representation of 10. So for all the integers from 1 to 10 should be represented in 4-bit format. So here we can see that 1 is represented as 0001. The actual binary representation of 1 is 1 itself. Since it should be represented in 4-bit format, we are adding 3 zeros at the beginning, because here in the question we can see that you must pad the leading zeros depending on the number of bits in the binary representation of n. The number of bits in the binary representation of n is equal to 4, and we are padding 3 zeros in order to convert the binary representation of 1 in 4-bit format. Similarly, when the integer value is 2, the actual binary representation is 10. To represent it in 4-bit format, we are adding 2 zeros at the beginning. So for all the integers from 1 to 10, we are doing the same process. So for the integer 8, we can see that the actual binary representation is same as the modified binary representation, because the actual binary representation itself has 4 bits. So we need not make any changes to the binary representation. And now, after forming all the modified binary representation for the integers from 1 to 10, we can see that only the integers 8, 9 and 10 have 1 at their first bit. Hence our output is 3. Now let us take the sample input 2. So for the input 16, our expected output is 1. So n is equal to 16. The binary representation of 16 is 1, 4 zeros. So the number of bits is equal to 5. All the integers from 1 to 16 should be represented in 5-bit format. So these are all the modified binary representation, and here we can see that from the integers 1 to 16, only the integer 6 has 1 in its first position. So this is the program which I have written in C language. Let us start from the main function. At first I have declared a variable n, and then I have accepted the value of n as the input. And here I have initialized another variable named num of bits in n, in which I am storing the value of bit count of n. So this bit count is a user defined function which I have defined here. So this function accepts an argument integer and then returns the number of bits present in that integer. So this function works like this. Initially I have set a variable named c, and then I have assigned the value as 0 to it, and then using a while loop until the value of the n becomes 0, this while loop would work. And inside the while loop, I am incrementing the value of c whenever n is divided by 2. By doing this, we could count the number of bits present in the integer n. And finally, when the value of the n becomes 0, this while loop would stop, and then we are just going to return the value of c, which would be containing the number of bits present in the integer n. Similar to the previous function, here we have defined another function named first bit, which accepts an integer in its arguments and returns the first bit value of the binary representation of the integer n. Let us see how this works. So here I have declared a variable named current bit, and this while loop works until the value of n becomes 0. Inside this while loop, I am setting the value of current bit as the remainder when n is divided by 2. So the value of the current bit changes in every iteration, and here for every iteration the value of n is divided by 2. So at the stage when the value of n is equal to 0, the value stored in the current bit would be the first bit value of the binary representation of the n. So we are just returning the current bit value. Coming back to the main function, here we have declared another variable named count and set its value initially to 0. And then here there is a for loop that iterates from n till 1, and inside that we are including a condition that checks whether the number of bits in I is equal to the number of bits in n or not. And whenever this condition fails, we can just break out of the loop and print the value of count. If this condition is satisfied, we are also going to check another condition. That is, we are going to check whether the first bit of the binary representation of the I is equal to 1 or not. And if the first bit of the binary representation of the integer I is equal to 1, we are going to increment the value of the count. And finally, after this for loop executes, we are going to print the value of count. Let us now understand why we are including this break statement with an example. So let us take the sample input 1. So here the value of n is 10 and the binary representation of 10 has 4 bits. So we are going to loop from 10 to 1. Here we can see that the binary representation of 10 has 4 bits and only the integers 10, 9 and 8 has 4 bits. All the remaining integers have less than 4 bits. So in that case, as per the question, we are given that we must pad the leading zeros. So zeros must be added whenever the number of bits is less than 4. So when 0 is added in the beginning, there is no way of possibility that the first bit would be having 1. So for all the integers beyond 7, it's impossible for the first bit to be 1. So instead of checking all these integers, we can just break and save our time. So this is the reason why we include break statement when the number of bits in the integer I is not equal to the number of bits in the integer n. So let us now check whether this program works or not with the given sample input. So let me give the input 10 and our expected output was 3. So here we can see that we get the output 3. So now let us give 16. Our expected output for 16 is 1. So we are also getting 1 as the output. So this is the logic behind today's daily challenge. Thank you for watching.